The deepest parts of the ocean get snow every day, and if it stopped for just a little while, whole communities on the seafloor would begin to starve. Not because they need light, not because they need plants, but because the deep ocean runs on a constant rain of drifting crumbs, dead plankton, tiny body parts, mucus, and yes, poop, falling out of the bright surface world like a slow-motion blizzard. Scientists call it marine snow, and down at around 4,000 meters, it can be the difference between life and nothing. So what is this snow? Why does it fall basically all the time? And how can something so small feed an entire world you never see? We're going to the ocean floor at 4,000 meters, the kind of depth that sits right in the neighborhood of the abyssal plains, huge flat regions that can stretch farther than some countries. There's no sunlight. The water is cold. The pressure is crushing. And the seafloor looks calm, almost empty, until you realize something is happening constantly. Food is falling. Not in dramatic chunks, not in big obvious meals, in flakes, in dust, in drifting specks that never stop. And if you've never heard of marine snow, you're about to see the ocean differently forever, because marine snow is one of the most important invisible processes on Earth. It is how energy from the sunlit surface gets delivered into the dark deep. It's a key part of the ocean's biological pump, the movement of carbon and nutrients from the surface down into the abyss. Let's drop. At the surface, the ocean looks like a single thing, one body of water, one blue sheet, but the ocean is stacked. It's layers of temperature, layers of salinity, layers of light. And the deeper you go, the more the rules change. At a few meters down, the sunlight is still strong. You can see color. You can see distance. Then you descend and everything begins to flatten into blue. Not because the water is empty, because the light is leaving. A few hundred meters down, the world is twilight. Shapes become silhouettes. You can feel the ocean get quieter in a way that isn't silence, more like the sound of distance. Then below the twilight zone, the sun is gone. Completely. Not dim, gone. And now your brain has a problem because humans are visual animals. We think dark means nothing. But in the ocean, darkness can mean everything is hiding. As you approach a few thousand meters, the temperature drops toward near freezing. The pressure becomes something you can't truly imagine, hundreds of atmospheres. Anything fragile is eliminated. Anything with a weakness gets punished. And at around 4,000 meters, you reach the abyssal plain zone. Vast, flat seafloor covered in fine sediment, clays and silts, plus pelagic sediments that drift down from above. This is where marine snow becomes obvious. Because in the beam of an ROV light, an underwater robot, the water isn't empty. It's full of falling specks. It looks like snowfall at night, caught in headlights. And here's the part that feels wrong. It's not seasonal down here. The deep doesn't get winter. It gets gravity, all day, all night. Marine snow is exactly what it sounds like, a shower of organic material falling from the upper ocean down into the deep. NOAA defines it plainly, a shower of organic material drifting from higher in the water column to the deep ocean. But the name can fool you. This isn't snow made of water crystals. It's a mix of dead or dying plankton, tiny bits of plants and animals. Fecal pellets, deep sea reality. Poop is part of the food chain. Mucus and sticky polymers produced by microbes and plankton. Dust and other inorganic particles caught up in the clumps. And the reason it matters is simple. Down at 4,000 meters, there is no photosynthesis, no sunlight-powered food production. So most deep-sea animals survive on what sinks from above, either as a constant trickle marine snow, or rare larger food falls like dead fish or whale falls. Marine snow is the everyday paycheck. Now if you're thinking, okay, so stuff sinks, why is that a big deal? Because most of that stuff doesn't make it. A lot of people imagine a direct delivery. Surface organisms die, fall straight down, and the seafloor gets fed. But the ocean doesn't work like a clean pipeline. The water column is an entire world of mouths. Bacteria, microbes, zooplankton, small fish. Life in the midwater is constantly eating, shredding, and recycling particles as they fall. In fact, many descriptions point out that most organic components of marine snow are consumed well before the particles ever reach the deep seafloor. One scientific review puts it bluntly: only about 1% of surface production reaches the seafloor. That means if the surface produces a huge amount of organic carbon, almost all of it gets eaten, recycled, or transformed on the way down. What arrives at 4,000 meters is the leftovers. And the abyss still survives on it, which tells you something powerful. Deep-sea life is adapted to scarcity in a way that's almost hard to respect until you see it. Now let's zoom in on the snowflakes, because they're not always tiny. Marine snow can begin as dust-sized specks, but it often clumps together into aggregates, little drifting clusters that can grow from millimeters to centimeters. How do they clump? Sticky biology. Plankton and bacteria release substances, like natural glue, often described as extracellular polymeric substances. Think of it as organic slime, but in a scientific, ecosystem-building way. That glue grabs particles. The particles grab more particles. And suddenly, what was invisible becomes a flake. And here's where the visuals get crazy. Sometimes marine snow falls slowly, like a gentle blizzard. Sometimes it forms larger aggregates that sink faster. A classic measurement of intact marine snow aggregates found sinking rates on the order of tens of meters per day, with one study measuring a range around 43 to 95 meters per day for intact aggregates in those observations. NOAA also notes that some flakes can fall for weeks before finally reaching the ocean floor. Do the math in your head with that idea. If a particle is falling for weeks, it's not dropping like a rock. It's drifting, tumbling, getting eaten, getting rebuilt. Marine snow isn't a straight fall. It's a journey through a living atmosphere, and that journey changes the snow itself. At the start, a flake might be rich, freshly produced organic matter, but as it sinks, microbes colonize it, they consume it, they respire, they transform it. The snowflake becomes a tiny moving ecosystem. It's like a sinking apartment building full of bacteria, and every meter it falls, something is taking a bite. So by the time marine snow reaches 4,000 meters, what arrives is often more processed, more used. Which is why deep seafloor animals can't be picky. They can't wait for perfect food. They eat what arrives, and what arrives is never guaranteed. So what does snowfall look like on the abyssal plain? Imagine a flat desert of mud and fine sediment. No plants, no sunlight. The seafloor is covered with a blanket of particles that have been raining down for thousands of years. Some of it is mineral dust. Some of it is biological remains. And scattered across this plain are animals built for low energy budgets. Sea cucumbers moving like slow vacuum cleaners. Brittle stars with arms raised to catch falling particles. Polychaete worms burrowing in the sediment. Small crustaceans and scavengers that treat every flake like a meal ticket. Abyssal plains are described as sediment-covered and vast, with pelagic sediments drifting down from above. Marine snow is a big reason those sediments exist the way they do, because the deep ocean floor is not only geology, it's accumulated history. It's a compost pile that never stops receiving deliveries. Now let's answer the title. It snows every day down here. Does it literally snow every day in every location? Marine snow is generally described as a continuous shower, meaning it happens year-round and is constantly present in many deep-sea environments. But the intensity changes. Surface life changes with seasons, with blooms, with currents, with storms. And that surface activity can send pulses downward. If there's a big phytoplankton bloom near the surface, a lot of biomass can die off, aggregate, and sink. That can create a heavier snowfall in the deep, like a storm front passing through, except the storm is made of biology. But even when nothing dramatic is happening, the deep still gets a steady fall of particles. That's why marine snow is often described as a staple, the everyday food source. Now here's the part most people don't realize. Marine snow isn't only about feeding animals. It's part of how the planet moves carbon. When surface organisms capture carbon through photosynthesis, that carbon becomes biomass. If that biomass is eaten near the surface and respired near the surface, carbon returns quickly to the atmosphere system. But if some of that carbon sinks, whether as particles, aggregates, or waste, and ends up deeper, it can be stored for longer. That's the biological pump concept, exporting carbon from surface waters to deeper waters. A microbial control review emphasizes that only a small fraction reaches the seafloor, but that small fraction matters because it is part of deep ocean carbon cycling. So marine snow is like the ocean's conveyor belt, taking surface carbon and sending it into the dark. Not perfectly, not efficiently. But at planetary scale, not perfect can still be enormous. Okay, so marine snow is real. It falls constantly. It feeds deep life. It helps move carbon. Now let's talk about how it feeds a world you never see. Because this is the part that's almost unfair. The deep ocean is the largest habitat on Earth by volume, and much of it is hidden from casual human attention. We see coastlines, we see coral reefs, we see surface waves, but the abyssal plain at 4,000 meters, most humans will never see it directly. The only reason we have footage of marine snow is because we send cameras down there. ROVs and deep-sea landers with lights that reveal the falling particles like headlights in a blizzard. NOAA even features marine snow as a recognizable sight in deep ocean footage. And in those lights you realize something. The deep ocean is not dead, it's just slow. And marine snow is part of that slowness. Because when food arrives slowly, life becomes efficient. Creatures move slower. They conserve energy. They stretch meals, they wait. Some deep-sea animals can go long periods with minimal food, then respond when a pulse arrives. The abyss is not a buffet. It's a rationed economy. Now let's make this personal, because a good deep-sea story always becomes personal. Imagine you're in a submersible, not outside, not in water. Inside a thick pressure sphere, you're staring out through glass at 4,000 meters. The seafloor is a pale plain. Your lights create a cone of visibility, and in that cone you see constant falling flecks. At first it's almost peaceful, like snow on a quiet street. Then your brain catches the truth. Every one of those flecks is a piece of something that lived closer to the surface. A tiny death, a tiny leftover, a tiny payment. And without those payments, the seafloor would go hungry. It's haunting, but it's also beautiful because it means the ocean is connected vertically. The surface and the abyss are linked by falling dust. So how do scientists study marine snow? They use a combination of cameras on ROVs and landers to observe particles in the water column, sediment traps suspended at depth to collect sinking material, water sampling and microscopy to see what the particles contain, chemical measurements to track carbon, nitrogen, and other nutrients, acoustics and optical sensors in some modern systems to track particle flux. The goal is to understand how much carbon is exported downward, what form it takes, and what controls its movement, because that ties into climate, deep-sea ecology, and the health of ocean food webs. And there's a key idea here. Marine snow is not just stuff falling. It's the result of biology, chemistry, physics, and time. Currents shear particles apart. Sticky polymers glue them together. Zooplankton package particles into fecal pellets that sink differently. Microbes colonize and break down aggregates. It's a dynamic system. Which is why one ocean region's marine snow can behave very differently from another's. And marine snow isn't always clean. This is where the story takes a modern turn. Because in recent years, Scientists have paid attention to how marine snow can transport things we don't want in the deep ocean. For example, harmful algal bloom toxins can become part of sinking material. Research News has discussed toxic marine snow and how quickly it can sink under certain conditions, carrying compounds downward. And then there's plastics. Tiny microplastics can become incorporated into aggregates and transported downward more efficiently than they would sink alone. The details and rates vary by study and conditions, but the concept is widely discussed in marine debris research. The uncomfortable reality is that the deep ocean is becoming a collector for surface problems. So the snow that feeds the abyss can also deliver pollution, food, and fallout together. Now, let's go back to the title's promise. It feeds a world you never see. What does that world look like? It looks like animals built to exploit falling crumbs, a sea cucumber crawling slowly, sweeping sediment, a brittle star holding its arms up like a net, a worm that lives in mud and processes it like a factory, small crustaceans that detect edible particles chemically, and microbes, always microbes, turning whatever arrives into usable nutrients. The deep sea is often imagined as a place of monsters, but most of the time it's a place of accountants, life that survives by budgeting energy, by taking whatever falls, by living on the margin. And marine snow is the reason those margins aren't zero. Here's a strange truth. If you could remove marine snow, you wouldn't just remove food. You'd remove the deep sea's rhythm, because the deep ocean food supply is tied to what happens above. Seasons change surface productivity. Blooms create pulses of sinking material. Storms mix nutrients and change plankton growth. Currents shift where particles fall. The abyss may look stable, but it's connected to surface events in delayed time. A bloom today can become a snowstorm weeks later in the deep. That delay is part of the mystery. It means the deep ocean is living in a different time zone. And there's another reason marine snow matters. It helps build the seafloor itself. Over long timescales, the accumulation of sinking particles contributes to the fine sediments that blanket abyssal plains. National Geographic Education describes abyssal plains as sediment-covered and mentions pelagic sediments drifting down from upper layers. That's marine snow's legacy. It's not just feeding life today. It's creating the ground life will crawl on in the future. Now, one of the easiest mistakes people make is thinking the deep sea is just a bigger version of the surface. It is. At the surface, life is powered directly by sunlight. In the abyss, life is powered by delivery. Food has to arrive. And since most of it is eaten before it gets there, the deep sea exists on a thin trickle. That's why many deep-sea animals have slow metabolisms. That's why some can go long periods between meals. That's why scavenging is so common. And that's why the phrase, "it snows every day down here," is not just poetic. It's literally describing the deep sea's supply chain. If you've made it this far, you've earned the core idea. Marine snow is the deep ocean's lifeline. It is the link between the bright world and the black world. It is a daily fall of energy and carbon and chemistry, dropping through kilometers of water, getting eaten, rebuilt, and transformed, until a small fraction finally reaches 4,000 meters and lands on the ocean floor. And that small fraction supports entire communities that would otherwise have nothing. Only about 1% of surface production reaching the seafloor is enough to keep a hidden world alive, because life adapts to what's available. And that brings us to a final thought that makes the deep ocean feel almost alive. The abyss doesn't need sunlight, it needs snowfall. A slow, constant rain of biological dust that never stops, even while you sleep, even while the surface looks calm. So next time someone says the deep ocean is empty, remember this. If your headlights could reach 4,000 meters down, you'd see it. A quiet blizzard feeding a world you never see. If you enjoyed this kind of real deep ocean reality, hit like and subscribe, because this series is going deeper, one true anomaly at a time. And in the next episode, we can follow the snow upward to the moving false seafloor that rises at night, an entire living layer so massive it can fool sonar. But for now, remember, down on the ocean floor, winter never comes. The snow does.